Okay, what we're looking at now is a thing called factorisation. Now, who's really dodgy with their multiplication? Who's really dodgy with their times tables? Okay, I'm really sorry for you because it's going to come back to bite you right now. Okay. Factorisation is about making something more simple. Okay. Heard of the term highest common factor? Yeah. So what's the highest common factor of, say, 72 and 36? What's the high? Oh, we'll start smaller. What's the highest common factor of 9 and 6? 3. 3's go into 9 and 3's go into 6. Okay? And the highest one is 3. 1's obviously going to it. Alright? What about the numbers 10 and 5? What's the highest common factor there? 5. 5's go into that, 5's go into that. If we get a gradually bigger, 10 and 40, what's the highest common factor? 20. What are all the factors? What are all the common factors of 20 and 40? What are all the factors?
20, 10, 5,
20,
10,
1,
2,
5,
10,
10,
2,
2, 4. Those that know their times tables would acknowledge that 4's go into 20 and 40. 2's going to 20 and 40, 10's going to 20 and 40, 5's, 1's and 20's. When they're asking for the highest common factor, okay, they're after that one, the highest common factor. They're all common factors. The highest one is 20. So my original question was 72 and 36.
36.
36. Okay. Those people that can quickly recall those numbers do it the easiest. Okay. Now that's all good with numbers. Certainly that's all good with numbers. That's stuff that we can do. I was going to do an exercise with you, but a lot of you don't have shoelaces. But if you were to have shoelaces on, I might just get you to spend a minute bending over and grabbing your shoelaces. So we're zoning back in here. Some of the processes we've done most recently, and you'll probably be sick of hearing it, is FOIL, perfect squares, and the difference of two squares. Okay, and the difference of two squares was just the sign in the middle of them. Everything else remained the same, so the x remained the same, the 4 remained the same. The only thing that changed there, that made them a little different. Okay, perfect squares was simply the same thing, all squared. Okay, and FOIL we applied to when there was two brackets alongside each other, but with sometimes different numbers. Often the same pronumeral, okay, or coefficient. So that is the process we've been through, and what we've been doing is we've been expanding those things. All of this process is expanding. FOIL, perfect squares, and the difference of two squares. In a very, and I don't mind the way this, I've been pretty critical of this book, but I don't mind the way they do this. In a very measured and basic process, we're now going to go the other way. And we're going to factorise. And we're going to factorise by picking out what the highest common factor of everything is. And don't look down into 12, D and E and go, holy hell, man, I'm never going to be able to do that. Okay? If you look at 12E and F, I reckon you'll think that. Okay? The reality is, you didn't start running the moment you finished crawling. Did you? Most of you. Okay? First of all, you tried to walk a little bit. You might have fallen over a few times, maybe smashed, maybe broken your face, something like that. But unfortunately, you might have. But eventually, you got walking, and then you got more confidence up, and you started running. but you persisted at it. Okay? Same analogy applies. So on these occasions, you'll be given this, and they'll ask you to factorise it. The common factor here is 3's going to 3, and 3's going to 6. 3's going to 3, 3's going to 6. Hence, that's why that's out the front. It's a common factor. What is left is an x, and to get this up to 6, it has to be multiplied by 2. So it's unravelling those shoelaces. It's going backwards. All right? But all of that there, as I've explained, is far beyond what you're asked to do to start with. The thing will be, though, that you do need to know your times tables. So, look, like we said with the last topic, it wasn't your algebra that was the problem for some of you. And Tish, can I use you as an example? Leading into the test, Tish straight away wrote a number line at the top of her blank sheet. Okay? So it's not the algebra that causes you problems. What causes you problems is number skills. The same will apply here. It won't be, oh, factorisation, God, it sucks, it's so hard, it's so horrible. It won't be that that's the problem. It'll be when, now who can I pull out here? Mr. Sullivan, did you ever have him? Yeah, or for those that went here, or Mr. Lambshed, or who do I know down at Butte? I don't really know anyone down at Butte. Any of those teachers said, learn your times tables, and you said, yeah, whatever, I know better. And now you'll be going, damn, wish I learnt my times tables. So instead of that, what I suggest is, just like the number line you had, I suggest on the back of a lot of your maths books you have your times tables. And in your diary. I'd just have them in front of me. Because most of the questions you'll be asked won't necessarily be, you know, factorise 1,933 and 678. It'll be around 8 and 12, 4 and 6. Okay.
Still letters.
Whoa.
So let us see how we can do this. Find the highest common factor of 8 and 12. Well, we know that the highest common factor of 8 and 12 is 4. 2's go into it, sure. 2's go into both.
Yeah.
But the highest common factor is 4. You can see that, Jordan, it really starts at baby steps. Okay? We're just identifying the highest common factor. The highest common factor here is 2. And what they're doing is they're breaking all this down to say, what do I have here? I have a 2 times a 2 times an x times an x. We've been doing that. Here, I have a 2 times a 3 times an x times a y. The common factor, they've done in red. A tactic you might use, because it may be a tactic which you employ that helps you. So the common factors is 2 and x, and we just write it as 2x. Okay? The long stage is we're going to be getting your perfect squares, your difference of 2 squares, and your 4, and working backwards. You know, but that's a long way down the track. When you learnt the alphabet, you eventually wanted to write words, sentences, essays, reports. You don't want to write reports probably anymore.
No.
But, or essays. But that was your ideal plan. That's what we're going to do here. We're going to start with the letters, probably literally, yeah? All right, we're going to start with the very basics and we're going to build up from there. All right? Are there any questions with this at this stage? No?
Nope.
Let us at them. You got a series of questions there in 12A. Your sheet in your book has some questions for you to do. Can you please go ahead and do them? And if you have any questions, shuffle your cups or ask me over and I will help you. So given you just had a little bit of a test, I'll just go through this with some of you. So if you look at the first one, 3x and 6, there is no x alongside the 6. So that's not a common factor. It's not common to both of them. Okay? The common thing here is the 3 and the 6, just the numbers, because the x doesn't really, you know, necessarily exist under the 6. All right? So the common factor here is, if my pen works, the common factor for the first one is just what, Jazz?
First one
A.
is oh yeah.
It's just 3. It's only the numbers that are common. If we look here, we've got a commonality of C and C plus numbers. So the common factor here, 9, 18, 27, must be 9, and the common factor is C. Which one? G. I reckon I've answered it for you. Alright. We have numbers and numbers. Because we have numbers, they must be the common factor. Alright, we don't have another X, so the only thing in my answer is going to be numbers. The common factor of 11 and a 12? 1. There is no other factor that they share that is common. Okay? Is that right? Common factor there would be 7x. Might be higher. 42. Might be that.
Oh,
Yeah, got one question.
I got 4.
Now, folks,